All right, so y'all go ahead and do the factoring and math knowledge question for today. Pause the video, and then once everyone is finished, y'all can unpause the video and I'll go over the correct answers. So for the factoring, you should have x minus 9 times x plus 8 for your answer. For the math knowledge question, which of these is undefined? You can do 0 divided by a number. That just equals 0. But if you try and do a number divided by 0, that does not exist. It is undefined. It doesn't work. So when this function is going to be undefined is when this denominator is going to equal 0. So x minus c, when it equals 0, that means x is going to have to be equal to c. So part 3 is the only one that would work, because if you plug in a or b, your numerator is 0, but it's okay to have a numerator of 0. You just can't have a denominator of 0. So only 3 would be your answer, which is C. Okay, so we're looking at lesson 3. We're going to look at the contrapositive, the converse, and inverse, and IFF means if and only if statements. If you took me for geometry, and I think last year in pre-calculus we did this as well, but if you took me for geometry, we covered these. They were not on the EOC, so if you took another teacher for geometry, 99% sure you have not really covered these very much. Usually they don't do them because they're not covered on the end of your test. However, I think they're helpful for you to know. So my students that have had me before should already know how to do these. So hopefully after this lesson you'll understand them. If you haven't ever looked at them before, you will have to spend a little bit of time studying to learn the difference, because they're all very similar. So contrapositive. We're going to start off with a conditional statement. A conditional statement is an if-then statement. So if you make a 100 on your test, then you made an A on your test. If you take out the trash, then you get ice cream tonight for dinner. Pick anything you want to make. If you're wearing red, then you're a boy today. Whatever you want. That's a conditional statement. If and then. Contrapositive and a conditional statement are going to be equivalent statements. That means that if the conditional statement is true, the contrapositive is also true. And if the conditional statement is false, the contrapositive is false. So the statement, if you're wearing a red shirt, then you are a male today. That statement, if it is true for whoever is wearing red, if anyone is wearing red, then the contrapositive is also going to be true. So a conditional statement and the contrapositive are basically just different ways of saying the same thing. So we're going to show you how to write the contrapositive of each statement. And I'm actually going to type it instead of write it out. So for part A, the contrapositive, you're going to take, I'm going to go back to geometry just for a second. P implies Q. This is the original statement. So the P is the first part here. Quadrilateral ABCD is a square. That's our P. And then this is our Q. Quadrilateral ABCD is a rectangle. So this is the conditional statement. The contrapositive takes Q and negates it. That little symbol means negate, negative, opposite. So not Q implies not P. And so for the first one, this is what it's going to look like. We're going to take our second part, so the then part, the quadrilateral ABCD is a rectangle. So if quadrilateral ABCD is not a rectangle, then not P. So our P was quadrilateral ABCD is a rectangle. So then quadrilateral ABCD is not a rectangle. You don't have to capitalize the not. I'm just putting it there to help emphasize. So you switch them and you negate them. So that's how you do that one. So I want y'all to try B, and I'm going to type it out. Once you finish, look up and see if you got the same answer as me. So your contrapositive should be, if f is not a continuous function, then f is not a polynomial function. So that's how you make the contrapositive. Just switch them and negate both of them. So that last part is dealing with calculus. They throw that in there. You don't necessarily know what a continuous function and a polynomial function are. You may know one or both of those terms, but they like to throw in calculus stuff a little early. But we'll learn more about those later. So the next one, again, this is dealing with calculus stuff. Differentiable and continuous, we will talk about that lots throughout the year. Right now, you have no idea what those are probably. Differentiable, you have never heard of this. Differentiable, differentiable, differentiable. So that's that word. So it gives us the conditional statement, and it wants us to make an equivalent statement that is also true. So what is equivalent to the conditional statement? In case you forgot, it's right up here at the top. The contrapositive. So the way you make the contrapositive is to switch your if and then statements and negate both of them. So it's going to become if function f is not continuous at point P, then function f is not differentiable at point P. So that would be your contrapositive. So that's how you make your contrapositive. Switch them and negate them. So looking at this one, you want to state the contrapositive of the following conditional. So y'all pause the video real quick and see if you can figure out the contrapositive by yourself. Okay, so the contrapositive, you switch and negate. If x is not an irrational number, then x is not a rational number. And whether or not that statement is true doesn't matter. If it's a rational number, then it's an irrational number. It's either one or the other. It can't be both. So if it's not an irrational number, then it's not a rational number. That it doesn't make sense. We learned that in lesson 1. But that's not important. What is important is just making the contrapositive. So I could tell you that all chickens have 10 legs, or if all chickens have 10 legs, then Henny Penny is a chicken. And then you're supposed to make the contrapositive of it. Obviously, chickens don't have 10 legs. It's not important. They're just wanting you to understand how to make a contrapositive statement. Okay, so now we're going to look at converse and inverse. So conditional statement and the contrapositive are equivalent statements. The converse and the inverse are also equivalent, not to the original and the contrapositive though. The converse and inverse to themselves are equivalent. So for the converse, I'm going to make a little chart for you to help you know about the original conditional statement, the converse, the inverse, and the contrapositive. Even if you had these in geometry, you probably still want to go write these. If you've never seen these before, this is going to be your little cheat sheet, little chart to look back at to help you with these. So I said earlier the conditional was P implies Q, and the contrapositive is not Q implies not P. Okay? So that's the conditional and the contrapositive. For the converse, your converse is just going to be Q implies P. All you do is switch your if and then statement. And then the inverse is going to be not P implies not Q. So that's your little cheat sheet that you're going to want to use. So looking here, our converse, we're just going to take our P and Q and switch them. So it's going to become if quadrilateral ABCD is a rectangle, then quadrilateral ABCD is a square. So that would be your converse. Just switch your two if and then statements. For the inverse, so for the inverse, you're not going to switch them, you're just going to negate them. You're going to put a not in there. You do want to make sure that your sentences make sense English-wise, so don't just say not just somewhere in there. It needs to make sure that it flows. So if the quadrilateral ABCD is not a square, then quadrilateral ABCD is not a rectangle. That would be your inverse. So that's how those work. All right, so looking at IFF statements, that is shorthand for if and only if. Math people like to do shortcuts when at all possible. So I am going to write IFF instead of if and only if. If you want to write out if and only if, you are more than welcome to. Just means you have to write more, but that's okay. So you're only going to have an IFF statement when both the statement and the converse are true. So you'll have to look at the statement, you'll have to look at the converse, determine if they're both true, and if so, then you can make an IFF statement. In geometry, you may have learned it as a biconditional. So biconditional may ring some more bells than if and only if. So like I said, IFF is read if and only if. You can put them together, your converse and your original statement. You can write them into one single sentence instead of having two separate ones. So looking here, if a triangle is equilateral, then it is equiangular. That is a true statement. The converse, if a triangle is equiangular, then it is equilateral. That is also a true statement. So the way that you put those two into one statement, a triangle is equilateral if and only if it is equiangular. And that is your biconditional, your if and only if statement. You could have said a triangle is equiangular if and only if it is equilateral. You could have used either one of them. It doesn't matter which. But that is your if and only if statement. So hopefully that jogged your memory on conditional statements a little bit. If you don't know conditional statements, you really need to look at that chart and learn them. You will have a question on your test that asks what is the converse, what is the inverse, what is the contrapositive, and if you get them mixed up, then it's going to be wrong. So you got to make sure you know those. So your homework for tonight is numbers 1 through 25. Again, if you don't have a graphing calculator, you might want to go ahead and skip down and try and do number 10 and 11. Those are two that say use a graphing calculator. So if you don't have access to one outside of class, go ahead and get started on those two first.